Hi, my name's Gary Taylor and I'm going to continue with MassTransit. And in this video, I'm going to have a look at messages. Remember, we are just having fun here. We're just playing about and trying to learn MassTransit. I'll do a series of better videos that explains things in a more concise way. But for now, let's just have fun. So today I'm going to have a look at messages. So if we go to the MassTransit website, we can see the messages section here. And there's a few things relating to this. And Mass transit is a contract defined code first, so you're able to create strongly typed classes or interfaces resulting in strongly typed contracts. It's quite interesting because in the previous um, documentation it stated not to instantiate classes, to really use interfaces and produce messages that way. So I'll have a look at that as we go through. So in typical fashion, here's a uh, interface that's going to do something. It looks like some kind of command to update customer's address, where we're going to send in some address details, and we're going to send that off to a queue. So this is where he says, he's got lots of experience in building queuing systems and messaging systems. So the idea to use interfaces is cleaner. It stops you putting any boilerplate code in, any calculations or methods that you would put into a class. You can't pass that across in a message. So you really want your message contract to be as close to a data transfer object, just data, no logic or business logic in there whatsoever, and certainly not anything that would have, inheritance or subclasses, because as he says here quite well, ooch. So we see a definition here, which is something I've not seen so far in the difference between commands and events, where I feel like a command is a doer, an event is a doner. You raise a command to say update customer address. And once the customer's address has been updated, you can then raise the event to say customer address updated. If you've ever done any kind of desktop application development, you get these typical type of events where you will update an address and then you'll say to the system that the address has been updated. So anywhere on the UI that has binding, it can go and refresh itself, and it can go and display the correct address now on the screen. And it's a really good way of being able to raise these type of events and separate doers from events. So a command tells the service to do something, and are typically, but not always, sent using the send method. And events then are echoing out to the ether to say that something's happened, and they are typically and predominantly sent using the published method. And it says here, which is quite interesting, that an event should not be sent directly to an endpoint. Now, an endpoint here, as we see, we can send to an endpoint, and then publish is saying we shouldn't send directly to an endpoint. And we can go into that further as we learn as we move along. My initial feeling right at the moment is that when we send, we can explicitly state a queue that we want to send to. And when we publish, we kind of just shout it out to the ether, and consumers can handle that. Now, the great thing about that is that multiple consumers can handle that request. And, if you want lots of things to happen when address has been updated, you could put them into 10 different consumers and they all get raised, they all get that event. But that's just my guess at the moment. So let's look into that as we go along. Right, message headers. So this is something that I find really interesting with mass transit, is when you fire up mass transit for the first time and have a look at some messages coming in, you might look at it and go, whoa, what's going on? My message is full of nonsense. just full of all this extra data. I sent a message in saying hello world, and my packet of message data is huge with all of these extra pieces of information put in. Now, for now, what I'd recommend is that we don't worry too much about that. Certainly don't try and clear the message out and remove all of these headers. But the idea is that we wrap, or I say we, MassTransit wraps a message in an envelope or in a predetermined collection of headers. So we can see things like the message ID. Well, that message ID is the unique identifier for that generated message. Every time a new message is pushed on to an exchange queue, then it gets a unique message ID, which is really cool. It means you can identify them things. A very good one as well is a correlation ID. Now, a correlation ID is a way of being able to correlate how two things link together. But what does correlate mean? So over in the UK, I'll give you an example. We had a doctor called, I think he was a physician called Harold Shipman, and he was also, unfortunately, a serial killer. So, because he was a physician, he was a serial killer. Therefore, all physicians are serial killers. We took two facts and merged them together and formed a false correlation. That's not true. Now, if you do it the other way, you can say that Harold Shipman was a physician. Therefore, because he was a physician, he went to medical school. All physicians go to medical school. That's a good correlation. That is a relatively truthful correlation. How does that relate to messaging systems? Well, it's quite common for messages to trigger other events. So like for instance, above, we might send an event out, which then issues a publish to say that it's been done, and there's nothing stopping them consumers from also sending other published events. Now, if that is, say, for instance, ordering some ice cream, and you want to order, you also want to take off the stock take, you also want to make sure that it's been sent to your marketing department, you need to be able to know where that correlated from. Why did you get that particular message? So the correlation ID is really good for being able to um, work out where that message came from. There are also other things which look a little bit similar to the correlation ID, which is like request ID, initiator, conversation IDs, and we'll cover them more in other videos. Then we have information about the source, the destination address, response addresses, and where the fault originated from, if there was a particular fault along the chain, expiries, and so on. All of these messages are very handy for the mass transit ecosystem. They're able to be utilized and passed down from message to message, and it also allows you to help debug when things go wrong, and you can see whereabouts in the chain things have gone wrong. I believe the idea came from good old-fashioned SOAP. Um, an envelope wrapper or wrapping something is a known pattern, and it is the idea that you would take a simple message or a simple bit of data and you would wrap it in extra bits of information. And here we can see with SOAP, there's headers, there's also a fault, which kind of relates to the headers we see here and a fault that we see here and more additional header data here. So you can see how a message that you want to submit to someone can be wrapped in more goodness that gives it value. So let's dive into an example. So messages are usually part of a conversation, yeah, and identifiers are used to connect messages to that conversation. Yeah, I think it basically saying what I just said in that, messages are generally not just a fire and forget, they're generally part of a bigger messaging system more, one calls another, calls another. A publisher might be consumed by 10 consumers and they all then publish. So it can grow into spider's legs or a tree probability of how these messages can spawn out. And being able to correlate them back to a single source would be very useful. Now the correlation ID, it's up to you what you call it. I think it's supposed to be a GUID. We'll look at that, but you're the person who sets it, because mass transit and messaging queues, they can't work out what it is that you're dealing with. So if you're trying to, what are we doing here? We're submitting an order, so we're going to have an order ID or a submit order ID. You want that to be a correlation. But if you're then doing like submitting a testimonial or making a machine in a factory spin round 3 times, that might have a different ID, and it's up to you what that ID is. So you can use it with the publish and the send. So you're able to set a correlation ID with both these types of emitters. Poor choice of word, but publish it and send. Then initialized via the underscore correlation ID. So I did this in a previous video as part of the mediator where we discovered that we could pass in extra header information with this underscore underscore that's not actually in your interface. And if we have a look here, there we go. So although submit order interface probably, or well, more than likely doesn't have this underscore underscore correlation ID, you can still pass it in. MassTransit works that out for you. Or if you wanted to be a little bit more concrete, you could actually go to the context of the send and pass it in using the correlation ID property of the context. It's just up to you, I think. If you're only going to need that, so you can use the underscore, but some people might feel that's a little bit sickly, like some kind of magic sugar. So let's give this a go. Okay, so let's try and create the project now. So I'm going to use .NET New Console. The name is going to be Mass Transit Messages. Let's dive into that once it comes to life. Empty messages. Let's open that up. Okay, so I've got just an empty hello world program now. So if I go back to here and do something that you should never do and copy and paste, and take this, let's paste this in here. Did I copy everything? No, you didn't. You made a right mess of that. In between the main. Can't even copy and paste right. There we go. Alright, so we need the mass transit goo. Mass transit prefers you to, well, the convention is to put the name usings in the namespace. I actually quite like it. So, mass transit. Okie dokie. Right, let's install the mass transit goodness. So mass transit and then .NET Core. Actually, I don't need .NET Core because it's just a console app. Obviously need RabbitMQ. Bus. Where's the bus going to be? There we go. So F1, just reload the window, give it a fighting chance after you included stuff. There we go. How are we looking? Let's do a .NET build. Oh, so it needs to be async. Can him copy and paste right? There we go. Submit orders, usage contract. So in the previous video, we saw where we use these interfaces. They're in their own separate project. So they were called event contracts, but for some reason they're called something else now. It's called usage contracts. But I'm not going to change that. I'm going to add the reference to the event contract, and then I'm going to use event contract. So .NET build. See if the errors go away. So submit order. Right, okay. I think the events contract doesn't actually have much in it. So we need a submit order. Yeah, there's not much in here. So new file, submit order, CS, value entered. Copy that, submit order. Submit order. Submit order has a property called order ID. The invar.id, that's a GUID. So let's GUID. Yep. Don't need to specify public or private because it's interface. Okay, so let's build. So that builds, but obviously code is still upset. It's not very good at determining them changes. So let's restart it, just give it a fighting chance. Looks okay. So submit order. If I have 12 into that, yeah, go to submit order. Cool. So let's run it and see what we're in. .NET run. Or I could have just F5'd it. Okay. So I'm not going to jump up and down and get really excited because that didn't seem to do anything. But then again, there's no code that really does anything apart from just puts a message onto a queue. So let's dive over. Okay, we've got our order service. That's bound to an order service queue. The queue is in there. And 2 ready? Did I run it twice? Don't remember running it twice. So if we have a look at the order ID. Right. Okay, so to point out the order ID and the correlation ID, they've got the same value. So if we have a look at the code, we're saying that, do they? Ah, of course there's two. There's two bloody calls here just showing you the two different ways of doing it. Moron. So there we go. We've got order ID. I'll take that one. Correlation ID. So the interesting thing and somewhat confusing thing is that here we're specifying that the correlation ID is the same as the message order ID. And the order ID has come from this static helper class. If I dive into there, this is just going to generate a GUID ID. So it's a really easy way of generating the GUID ID. However, it will give you that same ID for the whole, I believe it's the whole scope of this context. So if I call inver ID 50 times, I'm going to get the same value back, which is why we were able to call it here and here to pass it in, and it was the same value going into both. It saves you having to hold a temporary variable and then pass it into both, and that's okay. I personally prefer this way, but I get the idea in that. So with this, we are creating a new message. Once we've got a message, we call this callback and we can set the context. So now we can get the order ID, which has been set here, and pass it then into context. So create a message, construct it, get it up and running that's based off the submit order. Once you've done that, pass it to context, and when they're in context, we can then update the correlation ID. Or let's just do it all in one big whoop, and let's pass in using these magic sugar of the underscore underscore and set the correlation ID. So kind of personal choice, I would guess. So let's dive back to the website and see what we've got. Okay, so correlation conventions. You kind of need a thesaurus on terminology when you're reading through the documentation. The correlation can also be set by convention. In other words, we can set it another way using some kind of constructor or already implemented tooling that will put the convention of how this should work in place for us. MassTransit includes several different conventions, great, which may be used to set the correlation header. So there's apparently probably an interface, yeah, an interface that you can implement, which will basically put the correlation ID into your as a property. So if we have a look at that, if we look at the contracts, we could make this implement. Sorry for bouncing around. We could make this implement the correlation GUID by doing that. But of course, that then needs to be using MassTransit, which then means I need to include that project as a package into this very, very primitive project of just interfaces. And I'm not a fan of that. I know it doesn't matter, but I want to make sure that there is nothing in my interface apart from stuff that is absolutely required. Otherwise, what turns out to be just a contract property project ends up becoming something more. Message has a property of correlation ID. Okay, so if I just implemented a property of GUID and called it correlation ID with a get and potentially set, if I could actually type anything, then that would work and I would be able to use it. Let's have a look. .NET build. .NET run. Okay, go over to messages and let's refresh my messages list. Scroll down to the bottom, should have two from just now. 54, 53, yeah. So that's okay, but obviously because it's in the body, it's in the contract, it's actually ended up in the message, which I actually don't like. Now, there's probably some attribute that you can put on to say don't include, um, but generally when you need to put the attribute on, well, not generally, in all cases, when you put an attribute on, the code has to be there for the attribute. So if there's some special MassTransit do not include in message attribute, then I'm going to have to include MassTransit in my package for the interfaces, which I don't want to do. So actually doing it the other way with the magical sugar, um, actually it feels better to me in that scenario because we're not putting it into the actual message itself. So I'm just going to purge these messages. Let's clean things up a little bit. Okie pokey. Ooh, I've got a new touchpad and it's a little bit sensitive. Very sensitive. So another way of doing it, another convention, if you like, is to use correlation ID. So there is two. There's global topology or message correlation. So they're saying here that there's two ways of doing it. However, if you look under the hood, there's still just only one way of doing it. I guess it's one method that then points to another. So this used to be the previous way of setting a convention for correlation, and this is now the new way. So let's just, for now, let's just focus on that. If we have a look, what I think is happening here is that we're saying when we're setting things up and we're going to publish a message or send a message, then we're going to use a convention that for submit order, we're going to get the order ID and we're going to put it into the correlation ID. So let's take that and see if I am right. For that, I need to clean things up a little bit. I need to take that out. I need to take that out. Oh yeah, this returns the same value as I said before. Should have read the comments. Okay, global topology, which makes me feel like I can just stick this globally right at the top before anything. Okay, .NET Run. So it doesn't exist in the current system. So global topology. And luckily we've got it in an example. I love it when examples include the using statements. So kudos to MassTransit for that. It bugs me when you see a bunch of code and they don't tell you where that code comes from, especially with extension methods. It's almost impossible to find where they're coming from. Right, okay, that looks like that resolved that. Cool, we got that. Let's go to here. Oh, sorry about this. My touchpad is really sensitive. Queues, order service. Let's get messages. Let's take the order ID. I'm just going to copy and paste that. So we can see now properties. Here's the message ID, the unique identifier for that particular message. Here's a correlation ID. So all these messages relate to this order in some way. So if I have something else that publishes other things, it can use that same correlation ID because they all correlate to the same initial request. So that was a really easy way of doing it. And then further on, we published a message in a different way, and that also had a correlation ID set. Actually, it's not a different way, is it? I'm just doing it twice. It's just that one I had the context and the other I didn't. So actually, just that. But now I don't need to worry about setting up correlation. This system now knows that if I'm doing a submit order, I'm going to set the correlation ID based off the order ID, which I think is really cool. Okay, let's go back to the website. Okay, so, right, global topology. Um, Obviously, you can set up multiple buses, you can set up uh, multiple connectors to RabbitMQ and other queuing systems. If you use global topology, then guess what? You're doing this globally. You're setting that up for all buses with the looks of it. So yeah, global configuration shared by all bus instances. So if I made a series of bus instances, they would all do it. However, if you don't want that for some reason, you want a particular bus to handle that type in a different way, who knows? You just, when you're building these libraries, MassTransit has to be careful that they allow people to do these weird conditions. Once again, um, being opinionated and not allowing people to change is hard for a framework or a helper library. So here we're setting up the correlation, but just for this service bus. So let's see if I can demo that. Let's purge my messages. Okie, that's then purged. Let's take out that. Let's v2. And there was some configuration. Should never try and remember how to do it. Config, I should just copy and paste, but if you copy and paste, you never learn. This is why you should never copy and paste. So topology, right? Send topology, use correlation ID, GUID. Also, it looks like you could probably specify different correlation IDs. No, that's not right, is it? That's not the GUID, that's the thing that we want to base it on. So this is why the Lambda can work it out. There we go. Alrighty. So bus controller version 1 it's got it set. Bus controller version 2 doesn't. Let's start them both up. V2. Then multiple endpoints. I should have just extensioned this. V2 is bus controller V2, so apologies. I should have just wrapped this in an argument. V2. I just wanted to show both working simultaneously. .NET Run. So if I'm right from what I've read with the documentation, we've got two different buses. One is configured to use correlation and one isn't. They're both set to the same endpoint, so we're going to publish to the same queue. So if I go to the queues and have a look, we've got our two messages in there. Let's get them. So one looks like it's got the right correlation just from what I can see here. Let's just double check. Yeah. And then the next one has this order ID, and there's no correlation. Be careful when you're squinting. That's conversation ID. So the conversation ID, not correlation ID. So be careful. You can see here that if I take this message just to prove it, we can see that as part of properties we have this correlation ID. As part of the payload we have the correlation ID. So it was able to hoist that up. It's the same as the message ID. But if we look here, part of the properties got the message ID, no correlation ID, and within the payload, no correlation ID. So that was pretty interesting that we can choose how we want to set that up. So we can set it up globally for all of them, or we can actually do it individually. So if I purge the messages, get messages, if it's empty, why is it showing them? Yep, queue is empty, should clear it when it's empty. If I now change this back, so I'm just going to use the global convention and send my messages. What I'm expecting to see now is, even though I created two separate buses, the configuration for them buses is global. So the first one has a correlation ID, so the second one must have, yeah. So that's how we're able to set them messages, that correlation up. It's personal preference. So let's have a look next. Sagas. Well, I don't know what sagas are, so pretty much no point in reading this bit. But apparently they must have correlations, as it's the primary key, or the if you find some bit of data and you look at it, you want to be able to trace it. Like if you look at an address is great, but what does it relate to? It's got to relate to something. So maybe it's the address of an application. And if you look, or a quote, if you look at that quote, that might then relate to a customer, and that customer might relate to an umbrella of people who give you customers, or a particular bank or something, or some collection. So the when you go right to the top, the thing that uniquely identifies someone is that primary key, the thing that does them. In England, could look at that as being like your national insurance number. Only you have your national insurance number. So anybody else that's using it shouldn't be. It's primarily or primary your identifier. And apparently, in Sages, you must have it. So identifiers, they recommend you use GUIDs. Well, if you've not been under a rock for the last 10 years, then yeah, we should all be using GUIDs. Yeah. And some DBAs hate GUIDs. I mean, they're quite large. And if you have got a table that's only got some small primitive data in it, then to have a GUID as your primary key is using up more space than the actual data that it's wrapped around. Like for instance, if you have someone's age in a table, and the identifier or primary key was a GUID, then actually you'd be using significant more data and more memory just to hold the GUID than you would do the actual data itself. But also they're not 100% unique and they're not 100% incremental. So that can hurt some DBA's brains. But it looks like they've solved that problem here. So they're able to generate unique sequential GUIDs, which is pretty cool that they've solved that problem. You can use either the new ID or the GUID ID, enjoy the benefits of using it. There was also the invar static class, which gives you things like timestamps and ID, and even a correlation ID if you want to make one. Say, for instance, if you don't have anything that can identify that, you can pass that correlation ID in. Then if you send that within the actual body, which it has meaning then, so if you actually send that within the message object itself, then that has real meaning because you can store that in your database and you can say this is where it came from. So here we go, more just pointing out that we should be using interfaces. They've been doing it for years. So that's it. We got to the end. This was actually quite a quick one. So messages, correlation IDs, we have the ability to have all of these headers. These add value to the message, so it's wise to keep them. There are things that you can do to flush out and have just an empty payload. I wouldn't recommend it. Bear in mind your consumers know to have the ability to just go into dot messages to grab that, as we've shown when I was setting up the other things. So that's good. Commands to send and publish. One of the interesting things I noticed, which we've not really seen up until this point, is this structure here, which is setting up the endpoint. And this is basically setting up that we want to configure the queue and we want to go to the order service queue. Now, one of the things I really like about using endpoint send instead of bus send is that it was able to actually set up the exchange, the queue, and the bindings for us all in one fell swoop. Where in my previous video, we were using publish and we were just using the bus to publish, not an endpoint. It actually failed. Well, it didn't fail, sorry. It was worse than that. It published the exchange. There was no binding, so the message was just lost. Imagine if that was orders to your website, because there was no consumer and the binding wasn't there, you're losing all of them orders. And more to the point, you're not even aware that you're losing the order. And the whole idea of a queuing system is to stop that. So, this is a really nice way of doing it. Although stringly typed is not my preferred choice. Where when we were using publish, it was setting up the queues using the interface. So I'm just going to have a quick go of that. So let's clean that code up and let's try and use publish. New order, yep. So let's try and run that. Not even sure if that'll run because it's not configured. It does. And what do we get in the queue? Oh, keypad. So we're now getting event contracts submit order because we're using the publish and we've not configured an endpoint, so it's going to set it up for us automatically. It's going to set up the exchange automatically. But there is nothing linked to that exchange. There is no queue and there is no consumer. So that message that we just published out to submit order is gone, vanished, never to be seen again. Where when we used the send with the endpoint, we'd actually specified what we wanted the endpoint to look like. And because we put Q there, it's configured it automatically to create the exchange, the binding, and the queue. Something really powerful. Now, this is down to convention. There's an argument that why would you set up the publisher before you actually wrote the consumer? Surely, as an organization, you're going to write the consumer first, the bit that does the work, and then the thing that publishes it, you'll do it. So you get your consumer, you start it up, and it will fire up and connect the queue and map to the exchange. Then once you set the publisher up, you just publish, submit order. That'll send it to that, and everything will work like we've done in the previous video. So I see both sides. However, I really do like this events contract submit order. It's bound to the interfaces that you've created. It's all relates to these command and events, and it also means you know instinctively what your system does because you've got an interface, and you can also put documentation on your interfaces to explain what it is, what action's going to occur from this. So I really do prefer to use these event contract submit order type way of sets, you know, creating these types and these topics, these exchanges, but just be careful they don't automatically set up the queue, the binding. And that's the difference I've noticed. You can also set that as exchange, and I'm not quite sure whether, I don't think the bindings would be set up if that was the case. So let's give that a go, shall we? Docker ps docker stop some rabbit. I need to turn the sensitivity down on this keypad. So I'm just clearing things because I'm lazy. I don't want to go through and manually delete my exchanges and queues and things. So docker.net run. Hopefully everything's back up and running again. Should be. It takes Docker a few seconds to fire it up. Oh, helps if you spell it right. Exchange. Come on, it's only change with X. .NET run. Oh, so that ran. We can see order service. So that's the exchange. We're going to order service. There's no binding. Come on. There's no queue. So because I just specified exchange as the endpoint, it's going to go through. Now the weird thing is that you always go through an exchange. So even if I say queue, it's still going to send it to the exchange. It's just going to set up the queue for us as well. So there we go. There's a queue set up, but there's still the exchange, and messages are going to go through this exchange, as you can see here. You can see there's messages coming in. So it's it's going to do it. And I believe there was some table that I saw when I was digging around that showed me the list of things that it supports, the different um, queuing systems like RabbitMQ and ActiveMQ and things and what they support. And I believe, so take this as 50% truth, I believe that only RabbitMQ supported pushing just to an exchange. So keep it as the queue if you want to use this notation. Otherwise, use the publish if you like the interfaced way. And if you wanted to, you could always just make that the interface name. So you know there's nothing stopping you from doing it that way. Um, Configuring that is something we'll talk about in another video because it's probably further well it will be further down in the documentation when we start looking at the producers with send and publish. So for now, we've gone through messages, we've gone through this page. I think we've got a good understanding of what it's trying to tell us. Got a good understanding of correlations and different ways to set it. We also got a sneaky peek look at the setting the endpoint and using the queue and how we were able to set up the exchange, the queue and the bindings all in one fell swoop, which is nice. And the different ways of sending the messages and configuring the correlation. And finally, we looked at conventions or a known pattern for setting these things by either using the interface or using a global set or using a set just for the particular bus that we've created. Hope you like this video. In the next one, we'll be going on to consumers. Should be a quick one, I hope, because we've already covered quite a bit of consumer stuff. So that's going to be great. As always, smash on the like button and the subscribe button. Cheers, guys.